Welcome to the fourth entry in my organic chemistry reaction app, Devlog. I've said it before, and I'll say it again. OCRA is a chemistry puzzle game. My goal with this app is to make a game that rapid fires random chemistry puzzles at you so that you can grind out problems and develop an intuition for how chemical reactions work. So 90% or more of the app's code is for loading, drawing, and solving puzzles. And yeah, those three things are the core systems at play in the app. In the last devlog, I talked about what happens during the puzzle selection process. And that basically ends with an array of data that contains information about a single step in the puzzle. So this time around, I'm going to carry on with the description, and this time focusing on how the puzzle drawing system works. And puzzle drawing is basically how the app takes the information from the array that was generated during the puzzle selection process and then turns that into sprites on the screen for the player to interact with. But a little bit before that, a core guiding principle for this app, and maybe actually the core principle, is authenticity. I want the puzzles in my app to be real chemistry that's presented the way real chemists would present them and then solved the way that real chemists would solve them. So as you can imagine, this principle plays a big part in the puzzle drawing system. I want the puzzles to be drawn authentically. And so this is a picture of the chemical structure of ibuprofen. Then it's just taken from Wikipedia. So there's actually two pictures. One is a 2D representation and the other is a 3D model. The 3D model is good for getting an understanding of what the molecule really looks like since we live in a 3D world. But it's not very practical to draw because paper is two-dimensional. So chemists will often use the 2D representation unless there's a really good reason to go 3D. So if I'm trying to be authentic, my goal is to copy this same style that's shown in this image from Wikipedia and use that style when I'm drawing molecules in my app. So let's actually look at some of the features of this drawing style. So first of all, you'll notice that the bond angles are normally 120 degrees each. So when I draw my molecules, I'm going to target a 120 degree angle. Second, don't show hydrogen atoms. Technically, there are hydrogen atoms all over this molecule, but they really clutter up the picture, and showing them doesn't really provide much extra information, so usually they're omitted from the structure. Third, carbon atoms are basically just points where the bonds connect, and they aren't shown with their elemental symbol C. This is because carbon is a super common element in a lot of structures, and drawing C's everywhere is a real pain in the butt. So we kind of just skip it. This specific picture actually shows the CH3s at the end of the molecules. And that is an option for drawing, but another option is actually to leave the ends blank. There's actually a fourth principle, which is that bonds will usually zigzag. So you can see the structure of hexane in Wikipedia is basically a straight line, but with a zigzag pattern. And this is as opposed to the structure that I drew on the right, which is another way of drawing hexane, but without the zigzag pattern. Instead of the bonds, going back and forth, they keep rotating the same direction. You end up with almost a hexagon. Technically, there's nothing wrong with drawing it like I have on the right, but it's just not a common way of doing things. So usually it's a zigzag pattern like the hexane is shown on the left. You also note that this structure doesn't have the CH3s that the ibuprofen had. So yeah, both ways are valid, and I'm just going to go with the simple one of not showing any C's. So an overview of the puzzle drawing system then, basically it's going to do three things. First is actually to draw the molecules, which is spawning a series of sprites and assigning them their properties. And then after the molecules are all drawn, then the game will apply adjustments to their properties depending on certain circumstances. So this will include things like calculating the number of hydrogen atoms that are associated with each atom, adjusting properties if the atoms are positively or negatively charged, and spawning in lone pairs for each atom. And then finally, once everything is said and done and the molecules are all drawn perfectly, then they need to be moved so that they're positioned evenly spaced out on the screen for the player to actually look at, as opposed to them being hanging off to the side somewhere. So that's a broad overview of the puzzle drawing step. let's actually look at what this looks like in a real life example. So this, I had this table made in the last devlog. I used it as an example. And we're going to go over that in the app. Let's just drag that over to the screen here. So I made puzzle 222. So I have this pink arrow here. That is the molecule drawer. And normally it's invisible. I just drew a quick pink arrow so that you can see it. And basically what this is going to do is it spawns atoms and bonds, and then you can follow it along as it does that. So I have it programmed to go on click, so I can click and it spawns. In this I have it set to spawn an O here just for the first one. So this C over on the left is actually an O. Anyway, it'll spawn an atom, and then it will spawn a bond, and then rotate 60 degrees to form a 120 degree angle. And then it will spawn a carbon, and then spawn another bond, rotate, spawn the double bond, spawn a carbon, spawns, and it will keep sort of going like that, right, until you've drawn your molecule. So that's a basic gist of how the molecule drawing actually works step by step, using an on-click to draw each element as opposed to having it draw each element in a while loop. I do have another example which shows a little bit more of the complex stuff. So when molecules have to branch, then the game will store the properties of the molecule drawer. So things like, the rotation, the position, the current angle, things like that. So you'll start drawing a molecule as normal, spawn a carbon, spawn a bond, spawn another carbon, spawn another bond. And then when you want to start a branch, it will set that position, save it, and then rotate to start drawing the branch. And then you can continue along this branch until you're done. And then when it finishes the branch, it goes back to the original branching position to continue drawing more elements. The other feature, main feature, I guess, is rings. So when a ring starts, basically the rotation stops zigzagging and then keeps rotating in the same direction. So here we're going to start a ring, and normally it would zigzag up, then down, then up. But now we're just going to keep rotating clockwise as we spawn more stuff in. And every time a bond or an atom is spawned, it's also applying the start values and end values, hydrogen bond start values, hydrogen end values, things like that as it goes. And then of course you complete the ring and your molecule is done drawing. So those are, two quick examples of basically how the system works. There are limitations to the puzzle drawing system, and these aren't really problems with the system itself so much as it is a problem with 2D representations of 3D things. So this is a picture of a molecule that I made using a different molecule drawing software. And you can see in the two red circles that the bond angles aren't 120 degrees, because if they were, then things would start to overlap. And so the program did its best to present this, and instead of having it overlap, they just sort of made all the bond angles look ugly. So I guess, what I'm trying to say is that if my puzzles don't look the greatest in some cases, it's not really my fault. It's more the fault of the molecules for being super complicated. If it's a simple molecule, it shouldn't have any weird janky angles like this or overlapping problems. But the more complicated the molecule is, the harder it is to get a good representation of it without screwing things up. So it's not my fault, it's the molecule's fault. Molecules are just too complicated to be drawn well on a 2D surface, and that's just sort of a reality that chemists live with. There is one thing that you can blame me for, though. If the molecules are too big, not necessarily too complicated, just too large, could be a straight line, but it's just a really long straight line, then they don't fit on the screen anymore. And so I really should have a way for you to zoom out or change your view somehow so you can see the parts of the molecule that you need to see, and that doesn't exist yet. So you can blame me for that. Eventually, maybe we'll get there. So that was basically a bit of an overview of the puzzle drawing system. The puzzles have been loaded and drawn, and next up is to solve them. And I'll talk about that next time. Otherwise, update 1.0.1.6 is out. It's got new puzzles. It adjusts how fully randomized puzzles and user-selected puzzles are loaded again. This time it works, and I know it works, so I probably don't need to fix it anymore. I also added a squiggly bond, which is sort of an addition to the wedged and dashed bonds that I added last time. A squiggly bond is either a wedge or a dash. We just don't know which one it is, and so it sort of allows you to specify that it is one of these specifically, but we don't know which one. It's something that chemists use, so I added it. I also adjusted how rating changes are calculated, and it needed to be fixed a little bit because it's possible that your rating ended up as NaN, not a number. So you might need to fix that if your rating is NaN. You should probably reset that rating in the options screen. And then, of course, other than that, minor bug fixes that I've either forgotten or just don't feel like mentioning. Yeah, that's it for now. Thanks for tuning in, and I'll see you next time when I talk about how puzzles are solved.